You've seen how to add and subtract integers. In this video, we extend into multiplying integers. Let's start with an example. There are 5 oil derricks drilling holes that are each 35 feet below the ground. What is the total distance drilled? Express the result as a negative integer. Each hole drilled can be modeled by the integer -35. 5 such holes can be modeled by this addition statement. But this is an example of repeated addition, which can be modeled by a multiplication statement, as shown here. 5 times -35 equals -175. The product is negative because one of the factors is negative. The product of a positive integer and a negative integer is negative. Let's look at another example. A debit of $35 needs to be turned into a credit for the same amount. Show an integer multiplication statement that results in this credit. A debit of $35 can be modeled by the negative integer -35. The goal is to turn this integer into its opposite, positive 35. To turn an integer into its opposite, multiply by -1. In this case, multiply -35 by -1. Multiplying a negative by a negative makes it positive. So this equation shows how to convert a $35 debit into a $35 credit. Let's look at another example. A debit of $75 was mistakenly added to an account and needs to be turned into a 15-fold credit. Show an integer multiplication statement that results in this credit. A debit of $75 can be modeled by the negative integer -75. The goal is to turn this integer into its opposite times 15. We know that to turn a debit, which is negative, into a credit, multiply by a negative number, and not just any negative. We need to increase the absolute value of the original value 15-fold, which means multiplying by a factor of 15. So we take -75 and multiply by -15 as shown here. The result is positive 1125. Let's look at another example. How can you use arrays to multiply two integers? Use arrays to multiply these two integers, -3 times -4. We are looking to multiply -3 times -4 using arrays. An array is an arrangement of squares that model the numbers being multiplied, and we can use the Cartesian coordinate plane to model the multiplication. The 4 quadrants of the Cartesian coordinate system can be used to model multiplication using arrays. In this quadrant, 2 positive integers are multiplied and modeled with an array. For example, here is 3 times 4, modeled with an array. Notice that the result is positive, and the rectangle is in the quadrant that consists of positive x and y values. In this quadrant, a positive integer and a negative integer are multiplied. Here is the product of -3 and +4. The result is negative, and notice that the array is in the negative x part of the coordinate plane. In this quadrant, a negative integer and a positive integer are multiplied. Here is the product of +3 and -4. The result is negative, and notice that the array is in the negative y part of the coordinate plane. Now we get to the quadrant where both terms are negative. This rectangle models -3 times -4. The result is in both the negative x and negative y parts of the coordinate plane, but the product of two negatives is a positive, so the result is +12. Now we can see a visual pattern that shows a symmetry for the sign of the product. A positive times a negative, or vice versa, is negative, as shown here. The product of two positives or two negatives is positive, as shown here.